Hi everyone, hope all the exams are going well to date. What we're now going to do is have a look at the C3 last minute revision videos. So this is the 2016 question, this is the first one. Now I know my class don't particularly like the whole function questions, so we're going to have a look at that first and foremost. So we've got two functions here, we've got f of x equals this and we've got g of x equals this. Now we've got to solve the equation fg of x equals x. So first of all, this fg of x means that we've got to substitute our g of x into f. So f is 7 lots of x minus 1. So if we're going to substitute g into that, we're going to do 7 lots of this thing minus 1. So we're going to say that fg of x equals 7 lots of 4 over x minus 2 minus 1. So that's going to be 28 over x minus 2 equals 1. And what we're saying is we're going to set that equal, so minus 1. Equals 1 minus 1, and we're going to say that equals x. So then what we're going to do is we're going to rearrange and find the solution. So we're going to add 1 to both sides. We've got 28 over x minus 2 equals x plus 1. Going to bring this up so that we've got 28 equals x plus 1 x minus 2. Then we're going to expand the brackets. So using whichever method that you like, I'm going to use smiley face. But you get x squared minus x minus 2. Then you're going to set it equal to 0. X squared minus x minus 30. Then 0 equals x minus 6, x plus 5. So x equals 6, and then x equals 5. Sorry, equals minus 5. Hence or otherwise find the large value of a such that g of a equals f to the minus 1 of a. So this is all about trying to spot the link with the last question, because it says hence. Whenever it says hence, it means that you've got to use your previous answer. Oh no, it says hence or otherwise. It means that you can use a different method if you wish, but hence means that you should be looking at the previous answer. So if we've got here f of g of x equals x, then to get rid of this f, we're going to do f to the minus 1. So if you do f to the minus 1 on this side, f to the minus 1 on this side, what you've actually got is g of x equals f to the minus 1 of x, except just with a different letter. So we've got to find the largest value that satisfies this, which is the largest value that satisfies this, which in turn is this one. So we've got x equals 6. Okay, so that was that question. That wasn't too bad a starter question for the 2016 paper. However, the equivalent question on the 2015 paper wasn't nice. So to start off with, we've got show that g dashed of x equals some function of x e to the minus 2 of x when we've got this here. So if we've got g of x and we've got to find g dashed of x, that means we've got to do differentiation. So what we've got here is we've got a function times by a function times by a function, and we haven't come across that before. But if we concentrate on this bit here and multiply that out, we can say that g of x equals x squared minus x cubed. We're going to multiply that by e to the minus 2 of x. And now we've just got a function times by a function, so use the product rule. So we're going to say that u equals x squared minus x cubed. We're going to say that v equals e to the minus 2x. So du equals 2x minus 3x squared, and dv. Now remember, when you differentiate an exponential, whatever the power is, you differentiate that, bring it to the front, which is minus 2. And it's going to be e to the minus 2x. And then you do u dv plus v du. So u dv is going to be x squared minus x cubed times by minus 2e to the minus 2x plus v du, which is 2x minus 3x squared times by e to the minus 2x. Now if we sort this out by times inside by minus 2, we've got minus 2x squared plus 2x cubed times e to the minus 2x plus 2x minus 3x squared times e to the minus 2x, which is kind of looking like what we want to get it towards, but we've got one function times by something equals e to the minus 2x. So what we do is we're going to factorize out e to the minus 2x. So if we do that, we've got e to the minus 2x, and that's this thing, the minus 2x squared plus 2x cubed. So that's that plus this thing, which is 2x minus 3x squared. And then if we simplify that, it's going to be e to the minus 2x. It's going to be 2x cubed minus 2x squared minus 3x squared is going to be minus 5x squared. And then we've got a plus 2x on the end there. And that equals g dash of x. And we might want to write that in all of them. So g dash of x equals g dash of x. And this here gives us our cubic function. So now what we've got to do is we've got to find the range of g. So finding the range of g, the first thing that you need to know is that finding the range of g just means what can all the y values be. And it says hence. It doesn't say hence or otherwise, it says hence. So it means that we've got to use the part A to help us find the range of g. So how does that help us? How does finding g dashed of x, which is the gradient function, help us find the range of g? Well, usually when we find the gradient function, we set it equal to 0. And we've got a cubic function here. Or so when we multiply this out, we had a cubic function as well. So what we've got here is we've got our cubic function, as demonstrated by this. Now, if we set our gradient function equal to 0, that's going to give us this point here and this point here. So if we've got to find the y values, what we're going to do is we're going to work out what the y value is at this point here when the x value is 0, and here when the x value is 0. So that's what we've got to do. We've got to set our gradient equal to 0 to find these two coordinates. So this is our gradient function here. Now the e to the minus 2 of x never equals 0 because the exponential function looks like that. The minus exponential function would look like that there. Oh. And that, despite my awful drawing, never touches the x-axis. So this thing can never equal 0. So therefore we've got to make this thing equal 0. So we're going to set 2x cubed minus 5x squared plus 2x equal to 0. Now, first thing I notice is that there's an x in all of them, so let's do that. That's going to be 2x squared minus 5x plus 2. I'm going to set that equal to 0. Now, hopefully this will factorize, I think it does. So it's going to be x, 2x, and x, minus 2, minus 1. Yeah, lovely. So then x equals 2, and x equals 1/2. Obviously, x equals 0 as well. But we're not interested in x equals 0, so obviously that goes down there. So that's when that gradient is 0, when the gradient is 0 here, when the gradient is 0 here. So these are the x values. So 1/2 and 2. But we need to know what the y values are, because that's what the range means. The range is the values of y. So how do we work out the y values when the x values are these? We simply substitute them into here. So let's go ahead and do that. So we can do g of 1/2. So g of 1/2 equals 1/2 squared 1 minus 1/2 e to 2 lots of 1/2. So if we do that, it's going to be 1/4 times by 1/2 times by e to the minus 1, which equals 1/8 e to the minus 1, or 1 over 8e. So that's when g equals a half, or when x equals a half. So let's do g of 2. And that will equal 2 squared times 1 minus 2 times by e to the minus 2 times 2, which is 4 times by minus 1 times by e to the minus 4, which equals minus 4 e to the minus 4, or over e to the 4. So this is when g is 2, so that's going to be the least that y can be, and this here is the most that y can be. So we know the range of g, so we can say that g of x goes between minus 4 over e to the 4 and 1 over 8e. Right, now part C. State a reason why the function g to the minus 1 does not exist. Right, now the reason that the inverse function doesn't exist, and this can be asked in a bunch of different papers, but state a reason why the function g to the minus 1 does not exist. To have an inverse function, it needs to be a one-to-one function, but here you've got x equaling whatever this value is and x equaling whatever this value is, giving you the same y value. So therefore that would mean that g to the minus 1 of x would be a one-to-many function, which doesn't exist. So because g of x is a many-to-one function, or g of x isn't a one-to-one function, therefore it can't have an inverse function. So that's how to do that one. Let's have a look at the 2014 paper on functions. So the first one is kind of a nice question. I kind of like these questions. The first thing you do whenever you see a question like this and you've got to simplify it is you factorize. So the thing you can factorize here is this bottom. You've got x over x plus 3 plus 3 over 2x plus 1. If you factorize bottom, that's going to be x plus 3 and then x minus 2. And then if you're going to have two different fractions adding together, you can't add them unless you've got a common denominator. So the way you get a common denominator is you times top and bottom on the left one here by x minus 2. So it's going to be x bracket x minus 2 over x plus 3 x minus 2 plus 3 lots of 2x plus 1 over x plus 3 x minus 2. Then we're going to simplify the top. So if we do that, we're going to put it all over one common denominator, which is x plus 3 x minus 2. And that's going to be, if we multiply the brackets here, it's going to be x squared minus 2x. Then we've got a plus, so we don't need to worry about the signs. Then 3 lots of 2x and 3 lots of 1, so that's going to be plus 6x plus 3. And then going to simplify the top to give us x squared plus 4x plus 3 over x plus 3 x minus 2. And once we've done that, once we've added the fractions, we then simplify the numerator. So we're going to do that by factorizing. So x plus 3 x plus 1 over x plus 3 x minus 2. And we can see we can cancel out that on the top. So it's going to be x plus 1 over x minus 2, which is what they're after here. Find the range of g. So the range of g is simply, like we said beforehand, is all the y values. The way we find all the y values is that we see here that x has got to be greater than 3. So what happens if x is 3? So if x equals 3, we've got 4 over 1, which equals 4. So when x is 3, our y value is 4, but we're saying that x can't equal 3. So therefore, it's either going to be above 4 or less than 4. But let's see what happens then, because our x values can be above 3. Let's say we put in x equals, I don't know, 1 million, say. Then what we get here is 1 million 1,000,001. Yeah, 1,000,001 over 999,998. So what happens there, as x gets bigger, this is going to be just over a million divided by just under a million, which is going to be close to 1. It's never actually going to reach 1 because the top is always going to be a little bit bigger than the bottom. So therefore, it can't ever quite be 4 and it can't ever quite be 1. But it's going to go in between those. So therefore, we can say that the range of x here is going to be less than 4. So it can't ever equal 4, because remember, it can't ever equal 3. X is bigger than 3. And it's also going to get closer and closer to 1 without ever reaching 1. So therefore, g of x is in between 4 and 1. Now part C. Find the exact value for a, for which g of a equals the inverse function of a. Now, there's a couple of ways in which we can do this, and there's a long way around, which I'm going to start to show, and then I'm going to tail off, just because we haven't had a look at the inverse function yet. So the inverse function, if we've got g of x equaling x plus 1 over x minus 2, then the inverse function, what we do is we say that y equals x plus 1 over x minus 2, and we rearrange to get x equals. So if we bring this up to the top, that's going to be xy, so bring it up to the left, minus 2y equals x plus 1. Now I want to get all the x's on one side and everything else on the other. So if we bring this x over to the left-hand side, xy minus x equals 2y plus 1. Factorise out the x, so we've got x, y minus 1 equals 2y plus 1. So x equals 2y plus 1 over y minus 1. As soon as we've got x equals, we then write that as f to minus 1 of x equals, and then we replace the y's with x's, so 2x plus 1 over x minus 1. I know people do that slightly differently, but that's absolutely fine. That's how to find the inverse function. So what we're saying here is we're going to let, in fact, sorry, that was g of x, that should have been, sorry, g to the minus 1 of x. So what we're saying, or what this question's asking, is when this thing here equals the original function. So of course, what we could do is we could set them equal to each other, because after all, that is what the question's asking us to do. So if we did that, we'd say x plus 1 over x minus 2 equals 2 of x plus 1 over x minus 1. Then we try and solve that, and that would give us something really complicated, but again, it is something that we can do. However, there is a kind of, it's not a cheat method, but it's a method for knowing a shortcut for this. And we're going to have a look at the graphs in order to revise this. So what we've got here is we've got some function. So g of x could look like, I don't know, could look like that there. So this is g of x. Now, if we were to draw g to the minus 1 of x, what we do is we draw in the line y equals x, and then we reflect it in the line y equals x. So it would go through that point there, that point there. This would go up to here. This would go down to here. This would go up to here. And so you draw the inverse function. And so it would look like that there. And so it would look like that. Now, what we can see here by looking at the graph is a place where the function meets the inverse function is this point here. Oh, in fact, do it in a different color. This point here, this point here, this point here. Now, what we notice is that the places where they meet is on the line y equals x. So what we could do is, rather than setting this equal to the inverse function, which is harder, what we could do is just say, I want to know when x plus 1 over x minus 2 equals this line, which is just x, and then solve it that way. And that makes it a lot easier. Again, going through the video, we've had a look at how to sketch the inverse function, how to find the inverse function. But if we've got to find where a function equals the inverse function, just set it equal to x. So x plus 1 over x minus 2 equals x. Multiply through by x minus 2, which gives us x squared minus 2x, just by bringing this up and multiplying it by the x. And set it equal to 0, so x squared minus 3x minus 1 equals 0. that doesn't look like it's going to be very nice. So then we've got to use the quadratic formula or completing the square, whichever one you feel most comfortable with. I'm going to go with the quadratic formula. And that's going to be minus minus b, so that's going to be 3 plus and minus b squared, so that's going to be 9. Minus, I always put 4ac in brackets, so 4 times by 1 times by minus 1, all over 2a, so that's going to be all over 2. That's 3 plus and minus the square root. 4 times 1 times minus 1 is going to be minus 4, so that's going to be 13 over 2. But we know that x has got to be greater than 3, so we can't have 3 minus this. So it's going to need to be 3 plus the square root of 13 over 2. And that's how you do those ones. So, hopefully you'll go through the other videos as well, but good luck and well done for watching.